The first one ain't so bad, other than the fact that as we look at this, let me make sure my little green light goes on. Good. As I look at this, I notice that I don't have 25 on a scale. So I'm going to have to kind of adjust exactly how I get this done. And when that happens, I have to change the scale. I can't go each box as one. All right, so let's look at this first guy here. Negative 10x plus y is greater than 25. I'm going to add 10x to both sides. Can you all see that? Right? And that's going to give me y is greater than 10x plus 25. Did you all get that? Yeah. Okay. Now, what I noticed right away is that that's going to have a really hard time fitting on here. So what I'm going to do is I'm going to let each box represent 5. 5 I'm thinking because 10 and 25, 5 is the greatest common factor. So that's why I think I should use 5s. So I'm going to go 0 here, and then we're going to go like 5, 10, 15, 20, 25, 30, and then this will still be 1, 2, 3, etc. Okay? So in this case, my slope is up 10 over 1, and my y-intercept is 25. But I need to be very careful about that. When it says up 10 over 1, what does it really mean?
Up 2 boxes.
Right, up 2 boxes, because 2 boxes is worth 10. Does that make sense?
Yes.
Okay, so I'm at 25 here, up 2 over 1, up 2 over 1, up 2 over 1, backside. Now, is this a broken or a solid line? Broken, so I'll go with this. And do I shade above or below? I shade above because it's greater than. And there's my graph. Okay? So what this question really illustrates is sometimes we need to be flexible about our scale, and we need to be careful about our slopes, because it's not just that it says 10 over 1. 10 over 1 does not necessarily mean 10 boxes over 1 when each box is worth 5. 10 over 1 means 2 over 1, 2 boxes over 1. Okay, now the next one, what's weird about the next one? No x. That is one weird thing. There's another weird thing about the next one. What else is weird about the next one?
No x.
We just said that. I think it's weird that the y is on the right.
Why?
Right? Usually it's like y equals mx plus b. But do you notice how the y is on the right? It actually does. Because I'm going to need, look, yeah, here's the thing. If it points to the -6 here, it's got to point to the -6 here. Guys, stop. This is a very important point. Whenever you switch an inequality, guys, look here, don't look away. Whenever you switch an inequality, if it points to the number here, see how it's pointing to the -6? It has to point to the number here. So it's actually changed from a less than sign to a greater than sign. Now let me explain why this is really the same statement. Isn't it true if I say that Sylvana weighs less than Mr. Lindquist, or Mr. Lindquist weighs more than Sylvana? Isn't that the same statement? Okay. Likewise, I could say -6 is less than or equal to y, or I could say y is greater than or equal to -6. Otherwise, it would have said -6 is smaller than y, and if I didn't switch it, it would then say y is smaller than -6, and those two things are very different. Now, how does that affect my graph? Now, first off, there is no x here, so it's 0x. So what's the slope?
0.
Which means it's a horizontal line. So I'm going to go through -6, 1, 2, 3, 4, 5, 6. This is an or equal to, so it's a solid line. And since it's just y equals and a constant, it's a perfectly horizontal line. Remember, positive slope, negative slope, 0 slope. So it's a perfectly horizontal line. Now, do I shade above or below? Above, how come? Not because it's facing that way. Why do I know I shade above?
Because it's greater than.
It's greater than. Greater than is above, less than is below. So here's my graph. Now, doesn't this further make sense that all of the y's up here, be it 0, 10, a million, a billion, they're all greater than or equal to -6? Okay? All right, so the first graph talked about scale. The second graph talked about being very careful when you flip the line and also a slope of 0. Now the next one is a little bit weird also because now we have a slope of 7.5. And I would like to convert that to 15 over 2. Isn't that what 7.5 is equal to? In this case, negative. I'm again going to do each box on the vertical is worth 5. Okay? So when it says 15 over 2, that really means up 3 over 2. Do we all agree? Okay. So I'm going to begin at 15. 1, 2, 3. There's 15 right there. This is a solid line. I'm going to go down 3. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Solid line. I connect right there. And am I going to shade above or below? Below. Okay, so this guy emphasizes both the need for scale adjustments and the idea that I can convert this to a mixed number, or I should say an improper fraction, 15 over 2. And that gives me a normal slope. We don't have slopes with decimals. Slopes are always expressed in fractions. Okay? Any question on that? All right. So again, it's a little strange, but I think once you see it, it's logical and it makes sense. Are we good? Okay. Now, solve each system graphically and then algebraically. Now, graphically, go ahead, do it. I'll give you a minute or so to get this done. Minute and a half. I'll go through it graphically, and then I'll go through it algebraically. End the game. Okay. Now, first off, we look at this and we see right away that we don't need to change any scales or anything like that. And obviously, this is one of the ones that Common Core gave us as an example. Yeah, you can just tell by looking at it. All right, so y equals 4x minus 1. I'm using the skinny size here so it fits better on the graph. Slope is 4. Y-intercept's -1. So I begin at -1. Up 4 over 1. There's there. 1, 2, 3, 4 over 1. 1, 2, 3. All right, and I draw best as possible. Write the equation on there. Don't forget. Otherwise, you're going to lose points, so don't go forgetting that. Okay. Now, what's so nice here is that they're both in y equals form, so I really don't have to do any manipulating. So the slope here is -1/2. The y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. Down. Oh, I love it. That is music to my ears, or beauty to my eyes, whatever you want to say. Because it means that I'm almost guaranteed to be right. If you notice, I passed through a perfect point. That would be the point 2, 1, 2, 3, 6, 7, 2, 7. Did you check your answer? Let's check it and see if it works. Does 7 equal 4 times 2 minus 1? I will not tell Mr. French you said that. 7 equals 4 times 2 minus 1, right? I'm plugging in x and y on the first one. So 7 equals 8 minus 1. 7 equals 7, check. Then on the bottom one, 7 equals -1/2 times 2 plus 8. -1/2 of 2 is 1. Oh, pardon me, -1. Plus 8, so 7 is 7. Check. Okay, we're good. Any questions?
No.
Okay. So, all of that's set, all of that's done. Notice what it says on the directions. First solve algebraically, then solve algebraically. So now let's go back and do the whole thing over again using algebra.
When we take S and we don't do algebraically, it will be algebra.
Well, this is a teaching question. This isn't, like a graded
Oh,
thing.
but if
If it was graded, if it said both, you would need to do both. Okay? I get it. Never mind. All right, so here's the deal. How do we go about doing this algebraically? And the way we're going to do this algebraically is we're going to use algebra. But the one technique we taught you so far about algebraically was the elimination technique. And with elimination, we said we want like our x's over our x's, our y's over our y's, our equals over our equals, our numbers over our numbers. We want opposite signs, etc. That doesn't exist here. But we can still do it algebraically. What if I said to you, oh, by the way, you know what I'm really happy about? Going back to a year ago last August, so August 2nd of 2013, I got hit by the car riding the bike, hurt my shoulder, and I put about 20 pounds on after that because I couldn't exercise for the better part of the year, like 10 and a half, 11 months. And I didn't like that at all because I had worked so hard to get my weight down. And now since the surgery, I'm down 17 pounds. So I'm almost where I want to be. Except, wouldn't you know, right before Christmas, I turned around and bought myself a pair of bigger pants because the other pants were getting tight. And now I've lost 17 pounds, so the pants I bought that were going to fit are now very loose. That's these pants. So that didn't work out, but I'm happy I'm down 17 pounds. So this is a very, very good thing. So in the honor of pounds, let me really dream a little bit. And let's say I weigh the same exact thing as Sarah. Okay? And let's say Sarah weighs the same exact thing as, I'm really going to dream here, Kelly.
That's
Karen, I'm sorry. Now, let's say that Karen weighs the same thing as Sarah. Sarah weighs the same thing as me. What do you know about Karen and I? They weigh the same. If Karen weighs the same as Sarah, and Sarah weighs the same as me, what do you know about Karen and I? We have to be the same, right?
Yeah.
Let's put some numbers on it. Karen, my guess is you weigh about 95 pounds? 90 pounds? 85? 80?
somewhere near 80.
Somewhere near 80? Okay, so Sarah weighs 80. And if Sarah weighs 80,
Then you weigh.
I weigh 80. 80! 80! Now, if Sarah weighs the same as Karen, and Sarah weighs the same as me, then I have to weigh the same as Karen. So now, if Y,
Why would you?
if Y is equal to this guy. And y is equal to that guy. What do you know about these two guys? They have to be the same, don't they? The y is like Sarah. We said Sarah was the same as Karen, and Sarah was the same as Mr. Lindquist. So therefore, these two guys have to be the same because they're both the same as Sarah. Well, in this problem, they're both the same as y. So they have to be equal to each other. So what I'm going to say is that 4x, come on, get on there, turn on. Come on, you're losing dramatic effect here. 4x minus 1 has to equal negative 1/2 x plus 8. Now I just solved the equation using algebra. Plus 1/2 x plus 1/2 x. 4½ x minus 1 equals 8. Add 1 to both sides. 4½ x equals 9. What's 9 divided by 4½?
4.
No, come on. 9 divided by 4½.
5.
I can't believe you don't know that. 2.
There you go.
If stuck, use calculator. Now, so the first step is to get these things working together, set them equal to each other. Then I'm going to go back and solve y equals 4x minus 1. So y equals 4 times 2 minus 1, y equals 7. So x is 2, y is 7. I get the same solution either way, whether I solve it graphically or algebraically. They meet at the point 27, or I solve it algebraically. Now, this is not the elimination technique. This is called the substitution technique. It's called substitution because what you're saying is that you can substitute one thing for another. In other words, if the y is the same exact thing as this guy, then I can take this and I can put it in for the y. Okay? Who has a little courage here? Give me a guy that has a little courage, or a girl
What are we doing?
that has a little courage, is not afraid to possibly be a little embarrassed, not afraid to state their opinion publicly.
No. Yeah, I'll do it.
Okay,
I'll do it.
Andre?
Okay.
Andre, I need to know, in your opinion, who is the absolute most drop-dead, beautiful, stunning woman in the entire world?
I don't want to do this.
In the entire
Say your
world.
mom.
In the world!
I wanna do this.
No, you definitely don't want to say your mom.
You're weird to say your
Hold it, are you going out with somebody?
No.
Okay, good. You could choose, hold it, you are welcome to choose, like a Hollywood actress.
I don't want to do this.
You're welcome to choose like a singer.
Do this.
Leanne, do you want to do it for a guy? Okay. So, Leanne, who do you think is such an attractive male? Zac Efron. Now. Okay, now, anyway. So, Leanne, let me ask you a question. If Zac Efron came to your house and asked you out for a date, what would you say?
Yes.
Like, that's a kind of a stupid question I just asked, isn't it? Okay. So now, give me 1 second here because this is supposed to be lithium batteries. Okay. All right, so now he comes to your house. He asks you for a date. He takes you to whatever restaurant you want to go to. Let's say he takes you to Menino's in Oakdale, which is really nice. The minute you go to Menino's, you're looking at a $200 bill for 2 people, easy.
Well, you can pay for that.
Yeah.
This is exactly
It's very good. You will like it very, very much. So you go out to Menino's, you have a great date with him, you have a wonderful time. He asks you to go out again, and of course you say yes. Now, what if you woke up the next, or not even woke up, but you got home and you found out it wasn't really Zac Efron. It was his exact identical twin. Every detail the same. Is that still okay?
Yeah.
Oh, yeah, yeah. I tend to think that if Andre hadn't chickened out and he said that one of the most beautiful women in the world, whomever that might be, came to the house and asked him out on a date, let's say Kate Upton, came out and asked Andre on a date. Okay, now Parker, if it was Kate Upton's exact identical twin, would you be complaining?
Yes. I mean, no.
No, no.
I thought you you were gonna say really happy.
Ah. Yes, you would be very, very happy indeed. Now, when y is equal to 8x minus 1, or 4x minus 1, the y and the 4x minus 1 are identical twins. They are the same. The y is just as beautiful as Kate Upton. The 4x minus 1 is just as beautiful as Kate Upton. Both catch your attention. Right, Parker?
No.
Okay. Now, another example. Hold it. Another example that relates to real life. Let's say that you go down by the gym and you want to buy from a particular vending machine. And let's say what you're going to buy costs $1. But it says exact change required and it won't accept dollar bills. And you only have a dollar bill on you. How could you handle it and still get what you want? Andre?
Go to the cashier and get 4 quarters.
That's right. You could substitute or exchange 4 quarters for $1, because 4 quarters is equal to $1. So we call this the substitution technique. You could call it the exchange technique if you wanted to, because it says here, just like $1, I could say $1 is worth 4 quarters. I could say a y is worth a 4x minus 1. So here, instead of the y, I trade it in for the 4x minus 1, and then I can get an equation. See, I want to have an equation with only one letter in. When I have both a y and an x, I can't solve it. But when I can trade the y in for x's, now it's all x's, and I just solve it like a regular equation. I just have to remember when I'm done, just like with the elimination method, to go back and get the y. Okay? All right, let's turn a little bit more. Okay. This is an inequality graph. Go ahead, I'll give you about a minute and a half to get that done. Go ahead, 3 things to graph. Remember, an x equals line is a perfectly vertical line.
I thought that is in a graph.
Oh, that's a graph.
I didn't. But you said there couldn't be more than 1.91 y.
This is an inequality. You're shading. You're going to look for overlap shading areas. It's not an equals. It's not a line. You do the line and the shading, right? Both of them are solid. I think tomorrow's quiz is an inequality graph too.
I rock at these.
Do you feel better now that you won? You just feel better now that you dated Zac Efron.
Oh.
I'm praying if you don't
Leanne's in love.
Avery.
Ian, Leiter, Rexton.
It went down, right?
Okay, highly mathematical. Shh. You can't be highly mathematical on your plastic binder. Okay, come on, let's go. Perfectly vertical line. It's a no slope situation. We just said a line. Yeah, I know, I got you. A little too much Zach and a little too less math.
Stop, bro, stop.
Come on, highly mathematical. I'm sensing, I like talk, I just don't like when it's not about math. Okay. So the first one we're going to graph is x is greater than or equal to 0. Let's do a little thickness. Now, x is greater than or equal to 0 is actually known as the y-axis, kind of. Okay, it's solid line, because I got to go right through 0. And it's greater than, so I'm actually going to shade to the right. I know greater than usually means above. The problem is that you can't go above a vertical line. So isn't this the side where the x's are greater than 0? Right? So that's why I shade to that side. Now, next, y is less than 2. Now, we said that the y and a constant was a perfectly vertical line, but this is going to be a broken line. And y is less than 2 is going to go down here. Good. And now I need to do a little manipulating. Minus x, 3y is greater than negative x, divide by 3, and I get y is greater than negative 1/3 x, and if I want, plus 0. So, my y-intercept is 0, and my slope is down 1 over 3, down 1 over 3, down 1 over 3, backside. And this is a broken line as well. And this is greater than, so I shade above. Now, the only thing is, I need to shade in where they all overlap, which is right here. That's my solution set, where they all overlap.
I do not do that.
Okay? Does it make sense now that you have seen it?
Yeah.
Okay? Any question about that? Okay. Now, if you finished your homework the other day, you are completely done. If you had any questions, particularly near the end, there might be a couple that you didn't understand how to do because of what went on here, then you need to adjust. Okay? Any questions? Okay. Andre, if you need it, I have some Gorilla tape.
Oh, I found this.
Take your top back on.
But how, but the side isn't there either.
Oh, then now you're stuck, yeah.